Okay, hello everyone. My name is Alice Kisnia Putri. I am here to explain about my summary on our week 2 lecture. As what Pak Dai has explained in the class, I'm going to present my understanding about how to implement the AI5 as the approaches of the problem solving and cognitive processes. So without further ado, let's start the elaboration. In week 2, Pak Dai has explained about how to implement the AI5 to solve a problem. And Pak Dai has explained that the AI5 is a DAI-based learning that require two components, main components, which is that requires two ware, which is brainware and hardware. So what is brainware and hardware itself? Brainware is the cognitive aspect of problem solving. It requires logical reasoning, critical thinking, and analytical thinking. On the other hand, we have hardware. Hardware is the emotional and intuitive aspect of problem solving that involves empathy, creativity, and intuition. So, brainware, including the cognitive aspect, and when applying when we want to applying the AI5, we have to use brainware to utilize our analyzing the problem to understand the underlying principle and formulating the solution strategy. uh, while brainware handles the logical aspect, hardware plays the role to guiding the decision making, and after that we can find the solution. And in the class or lecture also mentioned about the step on learning using the I5. So as the part of the consciousness, we have to know first about the why, after that what, and also the how to find the solution. So these are the three components to on a learning process. Why, to understanding the purposes, what is the components of the learning task, and how to determining the strategies. So firstly, we addresses the why. Why concerns in understanding the purposes behind the learning task or problem at hand, and why involves questioning the significance of the topic or the problem, and it will provide the context and meaning to the learning process. And next we have what involves um identifying and defining the specific objective or the goals that require I'm sorry the components of the learning task or problem. So this step require breaking down the broader goal into manageable subcomponents or pieces of information that need to be addressed. So finally, we have how. How requires us to determining the strategies, methods, or approaches to achieve the divine objective that we have uh, considered in the current processes. So this step involves to considering the various learning techniques, problem solving, and methodologies are procedural steps that can be employed to navigate the challenges and achieve the desired outcomes. And also, in the slide, I'm going to talk about the computational thinking. So computational thinking will breaking down the problem into smaller, more manageable parts and devising the systematic approaches to solve them. But what is computational thinking itself? Computational thinking is a problem solving methodology that draws upon principle and technique used in computer science to address the complex problem. But it's not always to solve the computational problems, but also can be to approach the daily problem. We have four main steps which is decomposition, pattern recognition, abstraction, and algorithm design. Decomposition is breaking down into sub-problems. This step helps in understanding the problem, structure, and identifying the key elements. And pattern recognition helps to recognize the commonalities or regularities that can be leveraged to develop generalizable solution. And abstraction helps to simplifying the problem by representing in more generalized or abstract form. And then after that, finally, we have algorithm design. It will help us to developing the systematic approaches or strategies to address its sub-problem. So let's now take a look on the example. Okay, to illustrate this concept, let's consider an example of modeling population growth using the logistic growth model. We'll apply computational thinking principles to decompose the problem, recognize the patterns, abstract concept, and design algorithm to simulate population growth over time. Let's say that the problem statement is model the population growth of a species using the logistic growth model. I'm going to use Python to solve this problem since we talk about the computational, so that I am use this this software to solve this problem to find the growth model function over the time. And this is the code. I'm using the code code to use this, and the result is we have this graph to see the relation about the population and time of the logistic growth model. To simplifying the step, we have to define the logistic or what are the parameters of logistic growth. We have initial population, intrinsic growth rate, carrying capacity, time step, and total time. And then the equation. In this model, I'm use Euler method. And then after that, we can just plotting the population growing growth and visualize the result to observe the population growth curve. So these are the graph that we have. Okay. Thank you for your attention. I am Alice Kisnia Putri. Pamit undur diri.